that right now. Won't be that bad, Kristen. It won't be that bad. Think water polo. Just think water polo. Ah, ah, ah. Right. On page 363, and as Sepang put in the chat, if you've got the fifth edition, that would then be page 321. Right, now we're talking about saving. Now, initially we had talked about, in this case, your consumption, and we had gone to as far as A is equals to Y, or is meant to equal Y. There are two different scenarios around this, however. The first scenario is A being greater than Y. The second scenario is A being less than Y. And if A in this case is aggregate spending, Y is income and production. Now, as a result of aggregate consumption, or aggregate spending, I mean to say, being more than income and production, as an entity or firm, we produce more. On the other hand, if we have a situation where our aggregate demand is less than your production or income, then obviously we produce less. And this will become very important as we begin to start looking into further detail into Mr. Keynes' philosophy. The second idea that we had discussed was that A is equals to, in full, it's meant to be A is equals to C plus I plus G plus net exports. But in this case, all we do is we focus on C and I. Now, the beautiful thing about C and I is that we broke that up again. And consumption in this case, or consumption spending, was broken up into your autonomous and our autonomous consumption, and our friend Callum also put across the line, right? So just keep in mind it's the line. With induced consumption, and induced consumption consisted of our marginal propensity to consume and our income, and then we added our investment spending as well. Okay. So this is where we ended yesterday. Now, today we obviously want to talk about savings. And in this case, when we think about savings, I want you to think in this regard. Remember, our consumption function illustrates the following, that at the end of the day, a consumer will not consume their full income. There's always going to be a bit that they put aside. Now, as a result of this, it means that there's a specific amount of money that this individual is saving. Now, you guys will remember that your marginal propensity to consume will be 0, greater than 0, but less than 1. So, for instance, if this is 0.7, it lets us know that the marginal propensity for this individual is 0.7, but what it also means is that this person is saving 0.3 of their salary or their income. Let me know if that makes sense in the chat. Let me know if that makes sense in chat. Give me a thumbs up if it does. Thanks, Etienne. Great stuff. Great stuff. All right. Next idea is what we call an identity. Now, in this case, Y's identity is whatever consumption is plus whatever is being saved. Because remember, consumption will never be 100%. Whatever is left will obviously be what somebody is saving. Okay. Now, saving also has a equation as well. That equation goes as follows. S is equal to, which is savings, autonomous savings, plus the marginal propensity to save and income. Your autonomous savings, an interesting relation between your autonomous savings and your autonomous consumption is as follows. That your autonomous savings will always equal to the negative value of your consumption, your autonomous consumption. Now, you guys will remember yesterday as we drew the graph, that autonomous consumption would be around about there, right? Now, remember that we are still going to have this amount of autonomous consumption, regardless of whether we have an income or not, which is what this graph represents. But here's the interesting thing about that. Because this comes from savings, it automatically means that as soon as income is zero, this person will obviously draw from their savings. And therefore, when it comes to the savings function, I'll use another color for that. Whatever value you have of C, this is 0, this is S, and this is Y. Your autonomous savings will therefore start from below 0, being negative, whatever is the negative value of C. So in this case, if you have saved, or you have an autonomous consumption of 50,000, so you save 50,000, what will your savings then be? Let me know in the chat. If your autonomous consumption is 50,000, what is your autonomous savings? Callum says 0. Let's see some other attempts. It's fine. All right. Aria, let me know what your thoughts are. Dylan, Cabello, Kian, Kristen, Etienne, Sepang, Naledi, Tabian. Let me know. What are your thoughts? And remember, guys, what we're looking at here is this specific equation. Okay, all right. 100%. It would be negative 50,000 in this case. And the reason for that is that if we use this equation and we say that your autonomous savings is equals to your negative autonomous consumption spending, then if your autonomous consumption spending is 50,000, it will therefore be negative 50,000. Because basically this is where I'll start using my funds as soon as my income is zero. I hope that makes a bit more sense. I hope I haven't lost you there, Tabang. I hope that we found you. And everybody else, let me know. Give me a thumbs up if we're good. Callum, thanks for the attempt. Just let me know what your take is now. Would you understand that concept? Awesome. I'm glad. All right. So I'm going to shift focus then. So if you look at your graph, figure 17.3, the saving function, right? And just so you know, this is the savings function. You'll be fine, man. You'll be fine. So you basically start from a negative place and then you get into positive, right? And then this will obviously be your S is equal to your autonomous savings, which is your y-intercept, plus your propensity to save, marginal propensity to save, and whatever your income is. And the only thing that we have left to discuss just around savings, which I had mentioned, but I'll just put it out explicitly as well, is that you've also got to remember that your smallness, which is your marginal propensity to save, will always be equal to 1 minus your marginal propensity to consume. So if I know for a fact that I have a marginal propensity to consume, which is 0.7, then automatically it means that my marginal propensity to save is 0.3. Right. Let's just do some quick highlighting there, and then we'll shift into investment spending. So on page 363, it has there this identity right below Y C plus S. It says the identity indicates that this income must by definition be spent or saved. Since the decision to save is a decision not to spend, and vice versa, it follows that the factors that determine aggregate saving in the economy are essentially the same factors that affect aggregate consumption. Autonomous consumption indicates, and I'm still reading, that the level of consumption that will occur even when the income level is zero. This autonomous consumption will be financed by a decrease at an income level of zero. Saving will decrease by the amount of autonomous consumption. We thus express autonomous savings as follows. And then the next bit, the last bit on that right before investment spending would be the second sentence. Is note that autonomous saving will always be negative. Autonomous saving will always be negative. Very important, guys. This is because when the income level is zero, consumption will be financed by using past savings or credit, which we call dissaving. So the next time somebody says, hey, I'm using my savings to finance something, you can wag your finger at them and say, you're dissaving, right? At an income level of 0, the saving will thus be equal to the level of autonomous consumption. Great. Focus shift. And now we've dealt with C, being A is equals to C plus I, where C in this case is autonomous consumption, aka C with a line, as Callum put across, plus your induced spending, plus your autonomous investment spending. But now let's find out why. In this case, your I is autonomous spending. The third sentence in investment spending reads as follows: whereas consumption spending is the largest component of total spending, investment spending is more variable and less predictable than consumption spending. In fact, investment spending, called capital formation in the national accounts, is the most volatile of all components of aggregate spending, including those that are not studied in this chapter. On page 364, because it is so volatile, investment spending is often the main cause of fluctuations in economic activity. Now, investment decision. First paragraph. Why do firms purchase capital goods? In other words, why do they invest? The answer is simple. Firms invest because they hope to earn profits. They estimate the cost of the capital goods concerned and compare these costs to the amounts they expect to earn from investment. The greater the expected profit, the greater the investment will tend to be. If no profit is expected, there will be no investment. And then to the right of the page, you'll find in bold cost of capital goods. Let's start highlighting from there. The investment decision thus involves three important variables: the cost of capital goods, the interest rate, and the expected revenue to be earned from the capital goods. The higher the interest rate, the lower the expected return on the investment. Ceteris paribus. Similarly, the lower the interest rate, the higher the expected return on the investment. Ceteris paribus. In other words, there is an inverse relationship between the interest rate and the expected return on investment spending. Ceteris paribus. Now, what's important here to understand, guys, is that you'll see in that whole definition, and basically the relationship that we're deriving as well, is that at the end of the day, income has no business with investment spending, right? As we read that, we realized that there was no investment spending and income relationship. Investment spending is all about interest rates. So as a result of that, guys, this is why your investment spending is autonomous and has a line on top of it, simply because it is not dependent on income. It's only dependent on your interest rate. If we read a bit further, still on page 364, it says the equation for the investment function. As we have indicated, investment I is independent of the level of income Y. It is therefore autonomous with this respect to income. As in the case of autonomous component of consumption spending, we indicate the fact that an investment is autonomous by putting a bar above the symbol, or a line, if you will. Figure 17.4 then shows us an investment and the level of income as well. Okay. And you'll see there, as we did with our consumption function around autonomous consumption, that it's just a straight line, a horizontal line. And that horizontal line just simply indicates the following, that at the end of the day, income and investment spending are not related. Let me know if you've understood that thus far. Just give me a thumbs up if we're still on the same page. Figuratively, and certainly intellectually as well. All right, Callum's good. We have about 8 more individuals in the group. Let me know. Sapang, you mentioned that you didn't understand earlier on. Let me know if things are getting better. I'm glad, Kim. Awesome, Dylan. Okay, I will keep it moving then. Great stuff, Camilla. On page 365, we have the simple Keynesian model of a closed economy without a government. Now, here's what's important about this. And I want to walk through figures 17.5, A, B, and C. And I promise you, once we're done, you'll be like, really? That's it? In A, and you let me know if you want me to draw it onto the board as well. Okay, let me know via the chat. Like, also, can you please draw it if you feel like that might be a better way for you to obviously assimilate the information. Wow, I didn't even start, and it was like, just draw it, just draw it. I respect that. Let me do exactly that. So in figure 17.A, right, we have our consumption function, right? And we drew it yesterday. So this is not unfamiliar. And this was our consumption function being C, autonomous consumption plus induced consumption, right? This is the first graph, just basically illustrating what we've learned before. Now, what we're trying to do at the end of the day, guys, is that you'll see this specific equation. We're trying to make that happen on a graph as well. That's all we're trying to do, right? And I'll use another color for this. In B, however, you then find another situation where we have investment spending and income as well. And once again, illustrating that when it comes to investment, it's autonomous. It does not rely on income. It relies on interest rate, right? So we've got A and we've got B. But remember, we want to get this full equation put together. So we come to our next graph, and I think I'll use, let's use orange for this one, which is a summation of the both of them. Right? Now remember, because we're doing a summation of both of them, we obviously have on our y-axis, we have A, and on our x-axis, we have Y, right? A for aggregate spending, Y for income. Now in graph A, with the first graph, we only had C, where C, right, and this was autonomous C. But now we also have I as well, right? So it'll be C plus I. And as a result, we've had a shift. So that's meant to be more or less the same gradient. We've had a shift of our consumption line. And this is where now A, which is aggregate spending, is equals to consumption spending and investment spending. And this gap in between is the change in investment spending. So all we've done is we've taken both of these and we put them into one graph, so that at the end of the day, we have your A is equal to C plus I, then we also know this to be let me know if we're good to go. Awesome, Callum. Let's just wait for three more individuals. Great, Kian. Awesome area. Awesome, Kristen. Sepang, thou art giving me the silent treatment. Ah, yes, the lesson is being recorded. The lesson is being recorded. Okay, so I'll just continue then. So the next idea, guys, is that remember that we had what we call a 45-degree line. I see. I think when we start putting figures to it, you'll probably see what we mean. When we start putting figures to it, you'll see exactly what we mean. So if you can just give me a bit of patience there, Cabello, and once you put numbers to it, you'll then go, oh, I get it. Actually, let me just do that now. Let me not keep you in suspense, right? So we had your graphs, and I'm just going to do it all over again. We had your graph C. Let me do it properly. Firstly, we had your algebraic symbols, right? C plus I. Right? And then from here, we had autonomous C plus induced C plus I, right? Now, in the first graph that we had, we basically illustrated C, which is equals to C plus CY. In our second graph, as you put across, we just had a horizontal line, which was I, and this is investment spending Y, 0. Just make sure that I've labeled my graphs, get some good marks in that regard. Right. Now we're putting these two together. Now remember, there's autonomous consumption spending, and then there's autonomous investment spending. And we have to add these two together. And therefore, there's a shift. Because before we had autonomous consumption only, when we did C is equals to C bar CY. But now because we're looking for A, it means that we have to add your autonomous spending with your autonomous investment spending, and obviously your CY as well. And therefore, there's a shift because you've added both investment spending plus autonomous consumption as well. Does that make more sense, Cabello? And that's why the difference between these two is basically the change in investment spending. Let me know if that makes better sense, Cabello. Awesome. But it's not just enough for us to say, great, we obviously understand that A is equals to C plus I, right? Which is, and I know I keep repeating this, but as I said yesterday, repetition deepens the impression. And we want to make sure that we've got a deep impression when it comes to this. And this is a line. But we also know that A is equals to Y, right? And the line that shows that is what we call a 45-degree line. Ignore the other half. Where A is equals to Y. A is over here, and Y is over here. Now, what's important about this idea, and please make sure that you erase the following from your memory. That bit there doesn't exist, right? Now, what we try to do to understand this this full formula is to make sure that these two equate each other, right? Where these two basically would obviously meet. So if we put this line and this line together, we'll obviously get what we call equilibrium, right, between the two lines. But before we get there, the other important idea that we need to understand is that depending on which half you're on, when it comes to your 45-degree line, depending on which side you're on, you could have two different things happening. If you're on the top side, then you realize that it will be aggregate spending being greater than income. If you're below that, it will be aggregate spending is more than income or production. Right? And as indicated in the last session, remember that when aggregate spending is less than income, we produce less. However, when aggregate spending is more than income, we obviously produce a whole lot more. Okay. So we need to now figure out, and this is on page 366, figure 17.7, what happens when we put these two together? Now you'd remember that the line here for A is just simply A which would then be over here, A is equals to C plus I. 0, right? But remember, we need to put these two together. And the reason why we need to put these two together is to make sure that we get equilibrium. Right? And this can be shown as follows. So the first thing that I would do, and if you've got a pen and paper near you, you'd want to draw this as well. You have your y-axis, you have your x-axis. On your y-axis, you have aggregate spending. On your x-axis, you have income or production. The first line that I'll draw is my 45-degree line. Where A, aggregate spending, is equal to Y, right? And because it's 45 degrees, it's a 1-to-1 ratio. But remember, we also have another curve. And that curve is our aggregate spending curve. Which is A is equals to C plus I. Right. Just let me know in the chat whether you guys saw how these two graphs came together. And as a result, let me know where the equilibrium point would be as well. Where would the equilibrium point be here? And yes, you can put on your mic. That might be the faster option, but you can type it out as well. I'm going to give a minute for that. Where would the equilibrium point be here? You will not believe it. 100%. Where the two lines meet would be where there's an equilibrium point right over there. And as a result, guys, sorry, that was meant to be dotted. This is where you have your aggregate spending, and this is where you would have your equilibrium level of income. So your equilibrium level of aggregate spending and your equilibrium level of income. Okay, where these 2 points intersect. What's further of importance would be the following: these shaded areas. Now in the first area, guys, I'm going to just put area 1 and I'll put area 2 over there. All right. In the first area, which is bigger, aggregate demand or aggregate supply in the first area? Everybody else, what are your thoughts? Okay. And obviously in the second area, you'll have aggregate demand being less than income. Now remember that the point at the end of the day is always to get to the equilibrium points. So as a result, depending on where you fall, your firm will obviously have to either produce more or produce less. Okay. Now, let's do some quick highlighting on page 365. Some quick highlighting. Before the break, on page 365, under total spending or aggregate demand, it says we have established that consumption C is primarily a function of income Y. We've also established that investment I is not a function of income Y. These two relationships are illustrated in the figure 17.8 to B. To obtain aggregate spending, we have to add C and I at each level of Y. This yields the total or aggregate spending function in figure 17.5. We also know that there is equilibrium when aggregate spending A is equals to total income Y. We therefore have to establish at which point along the A curve aggregate spending is equal to total income Y. This is done by using a 45-degree line. Still going. Underneath the 45-degree line, it says in figure 17.6a, we have total spending A on the vertical axis and total income Y on the horizontal axis. If both axes are drawn to the same scale, a 45-degree line running through the origin represents all points at which total spending is equal to total income. This line therefore shows all the possible equilibrium points. On page 366, second paragraph, second sentence in that paragraph. Sorry, third paragraph, I mean to say. Second sentence in the third paragraph on page 366. It says all points above the line, we're talking about the 45-degree line, indicate excess demand, and all points below the line indicate excess supply. Guys, there's going to be a lot of repetition. I've already said it, but remember, repetition creates a deeper impression. Then the last sentence in that paragraph on page 366 says, in the figure, it is shown that the income level at which the aggregate spending function A intersects the 45-degree line, where your aggregate spending level of spending is equals to your aggregate is equals to your equilibrium level of income. At any other level of income, there is either excess demand or supply along the A function, and therefore an unplanned change in inventories. Okay. Right, guys. The next idea that we're going to do is basically now start using words to define everything that we've done. It will be repetition, and then we're going to use symbols, we're going to use graphs, and then we're going to use numbers as well to illustrate these specific points. Trust me, it sounds a lot more complicated, but once we start working things out, I promise you that things will obviously begin to get simpler. So let's take a quick breather, a good, in this case, I'll give you, let's say, the full 14 minutes. At exactly 4 o'clock, we'll come back and we'll work through the rest of this specific chapter, or as far as we can get. All right. And if you have any questions, feel free to ask during that 14-minute break.